Hi, kids.
Hey, kids.
Me and Mr. Aiden here, we're just hanging out at the Cubs game because
Yeah.
it's so gorgeous
It
outside.
is beautiful.
Minus you're wearing a coat, but whatever.
Oh, well, you know.
The breeze comes off the lake. It's a little chilly.
Just a little. You know, this year, it's their year, 2015, right?
Right, yeah. Back to the Future, they said they're going to win the championship.
That's right. So I hope to get that DeLorean.
Yeah, I would love one of those.
Oh, that'd be great.
So, we got some delicious popcorn because, of course, you can't go to a baseball game without popcorn.
Of course.
So, and we're just going to jump right into it, and we got a little reviewing of States of Matter we're going to go through.
All right.
Here's our three little fellas, solid, liquid, and gas, just to give you a little fun chuckle with you.
All right, so the first thing here, we'll talk about solids. Okay, just a review again. So molecules are tightly packed. Okay,
So that means, wait, I got a question.
Okay.
Does that mean they're like sitting on top of each other, kind of?
Yeah, so they're right on top of each other. There's no room to move whatsoever.
Okay, got it.
The molecules are moving very slowly, so there's very little energy there. They're practically just vibrating in place.
All right, I got that so far. So they're just real tight to each other.
Real tight.
Okay.
So like, you know, the 8th grade dance when they're moving really slow,
Ooh.
dancing back and forth.
Got it.
You remember
got
that,
it.
right?
I got
Right?
it. Perfect.
So there's a definite shape, definite volume, which means it does not change.
Okay. So like kind of like our bowls of popcorn.
That's right.
They can't change unless I break it.
Unless you break it.
Okay, got it. And it holds a
All right.
specific amount, right?
That's right.
That's what the volume part means?
The volume doesn't change. It's a fixed amount the whole time.
Okay, cool.
All right, so the next one, liquids here. Molecules are moving more loosely packed than a solid.
So this is more like the freshman at the dance then, right?
That's right.
A little bit more room to shake it.
Yeah, that's right. You know, they're a little more confident. You
Okay.
know, not 100% yet, but, you know, starting to get a little loose there. Molecules moving a little bit faster than a solid.
Okay.
You
They're
know,
not quite at that senior level of twerking yet, right?
Not yet.
Okay,
Not yet.
got it.
They take the shape of its container, okay, so which means that their shape can change depending on what the container is.
Oh, so like if this was like a cylinder, or popcorn would take a cylinder shape instead?
Instead
Okay.
of a bowl shape.
Got it.
But, however, the volume will not change, even
Okay.
though the shape is changing.
So if I fill my bowl here with water and then I pour it into a cup, it'd still take up the same amount of space.
Correct.
Okay. All right. I get it. Makes sense. And that's what this picture looks like down here, right? What
That's
our
right.
molecules are looking like?
Yeah, a little more disorderly.
Okay.
The last one here is your gases. Okay, now these molecules are moving very fast. They're very loosely packed.
These are the seniors twerking.
These are the seniors twerking. Okay, just going all out.
Okay.
Letting-
And of course there's plenty of space, so they're like bumping into everybody.
That's right. Yeah, they
Okay.
bump off each other, and they start dancing a little more, and they hit another person. So
All right.
no definite shape, no volume. Okay, so that whatever container they're in, they fill up that container. Whatever volume they have, it will constantly change no matter what.
Oh, okay. So then they always got room to move, right?
That's right.
Okay.
They have plenty of space. They're always moving.
All right. So let's take a quick peek what they all look like kind of together.
Okay. So if you start at the left here, solid Hg, aka mercury.
Okay.
Okay. They're really tightly packed. Okay. The molecules there are practically right on top of each other. No
Oh.
movement at all.
So
No.
like when you toss out food for the pigeons and like all of them land on it.
That's right.
Okay.
They're all
Right on top
right
of
on
each
top
other.
of each other, trying to get that one piece of popcorn.
Got it.
The next one here is liquid mercury. Okay, you notice here the molecules are starting to get a little more loose. Okay,
Mhm.
they're not as tightly packed anymore. They're wiggling around a little bit more.
Okay. And that's why they can move like on a table or a surface or something, right?
Correct.
Okay.
And then finally, in the last state here, the gaseous state, there's a lot of room. Okay, they're flying all over the place. They're banging into each other.
Got it.
Plenty of room, plenty of energy.
Kind of like kids at a playground.
That's right.
Got so much energy
Energy.
and they just are
Yeah,
everywhere.
everywhere. Not looking where they're going, running into each other,
Ugh.
bloody noses, everything.
Jeez. Sounds horrible.
And the last thing, reactions. Now, as you remember, these speed up a reaction.
Oh, kind of like when I made a mess on the ceiling.
That's correct.
Okay.
Ms. Keiser added too much potassium iodide, and kaboom!
And
got a nice
I had
big
a
brown
little bit of
stain
a
on it.
mess. Got it.
That's
Yeah,
right.
I remember that. And if I'm not here next year, you know why.
That's right.
But we got we're gonna have another little clip here for you so you can see just a reminder of what it looked like. But that catalyst speeds it up. If you can remember when we did this demo in class, we took 30% hydrogen peroxide added some Dawn dish soap, and in this case, they put food coloring for some color added effect. And right now, they're about to pour their potassium iodide, which is that catalyst. And of course, that catalyst is what speeds up the reaction. In this case, they had quite the amount. And if you can see, you could see some steam raising off of there, okay? That steam is because, of course, it is releasing heat. And the release of heat is exothermic, because heat is leaving the system. It's kind of like, I guess, like when someone's like hearing people talk smack.
That's true.
And then someone comes in and says, hey, I just heard something else. It like makes the guy more reactive, ready to fight.
That's right. That's right. Exactly.
All right, I get it. Cool.
Okay.
All right.
Any questions?
I think I'm good.
All right.
See you guys in class.
See ya.